All right, so let's start with differentiating the function y equals the square root of 5 plus cotangent squared of x. So the first thing we want to do, recognize that the square root function is the same as the 1/2 power. So we can rewrite that as y equals 5 times cotangent squared of x raised to the 1/2 power. Now to differentiate this, we're going to use the chain rule because we have an outer function, which is the 1/2 power, and the inner function, which is 5 plus cotangent squared of x. So dealing with the outer part, we apply the power rule. That yields 1/2 times 5 plus the cotangent squared x raised to the negative 1/2 power. Then we multiply that by the derivative of the inner function, 5 plus cotangent squared of x. Now 5 is a constant, so its derivative is equal to 0. We differentiate cotangent squared of x. That's also a composition, cotangent of x squared. So we apply the power rule again there. It gives us 2 times the cotangent of x. And then we multiply that by the derivative of the cotangent function, which is negative cosecant squared x. So all that's left to do here is just do a little bit of cleanup. The 1/2 and 2, we can multiply those together. They kind of cancel out, give us 1. And so bringing out the negative cosecant squared and cotangent out in front, we'll have negative cotangent x times cosecant squared x multiplied by 5 plus cotangent squared x to the negative 1/2 power. All right, and that's pretty much our result. We could write the 5 plus cotangent squared of x to the negative 1/2 power. We could put that in the denominator to make it a positive exponent, but this would be sufficient for a correct answer here. So for the next problem, we have an initial value problem. So we want to find the function v of x, given that v prime of x is equal to 4x to the 1/3 power plus 2x to the negative 1/3 power, and that v of 8 is equal to 41, with the condition that x is greater than 0. Now, that condition that x is greater than 0 is relevant because since x is being raised to a negative power, we want to make sure that x is not equal to 0 or we'd have an undefined result. So we're just keeping everything positive. So that's good. So now, of course, if we want to find the original function given the derivative, the first thing we want to do is we can find the function or the general antiderivative by taking the indefinite integral of the derivative 4x to the 1/3 power plus 2x to the negative 1/3 power dx. So now integrating this term by term, for 4x to the 1/3 power, that'll be 4 times x to the 4/3 power divided by 4/3. For the second term, you've got 2 times x to the 2/3 power, adding 1 to negative 1/3 gives you 2/3, divided by 2/3, plus Uncle Charlie, plus c. Now we clean this up a little bit with dividing by the fractions. It's the same as multiplying by the reciprocals. So that's 4 times 3/4 x to the 4/3 power plus 2 times 3/2 times x to the 2/3 power plus c. So our general solution gives us 3 times x to the 4/3 power plus 3 times x to the 2/3 power plus c. Now, this is our general antiderivative, but we want to find the specific function that meets the initial condition. So in this case, we're given that v of 8 is equal to 41. So that means that we're going to replace, that means that when we replace the x with 8, that means that our function v is going to be equal to 41. So if we plug that in or substitute that into our general solution, we end up with 41, and then we replace the x with 8. So this would be 3 times 8 to the 4/3 power plus 3 times 8 raised to the 2/3 power plus c. And so we want to solve this equation for c. I'm going to skip a couple steps here. 8 to the 4/3 power, that's equal to 16. And 8 to the 2/3 power is equal to 4. Our equation is 41 equals 48 plus 12 plus c . 48 plus 12 is 60. And then subtracting both sides by 60, we get c equals negative 19. So therefore, our solution here, our specific solution, is 3x to the 4/3 power plus